Of exercise 2.7, questions number 1. The equations of a curve is y equal to 9x plus 1 over x for x is greater than 0. A1. Find the gradient of the tangent to the curve at x equal to 1 over 4 and x equal to 1. To find the gradient of tangent, we need to substitute the x-coordinate of that point into the dy dx. For the equation of the curve, I can write this as y equal to 9x plus x to the power of negative 1. Then dy dx will be 9 minus x to the power of negative 2. This is the same as 9 minus 1 over x squared. At x equal to 1 over 4, then we're going to substitute the x here with 1 over 4. Then the answer is equal to negative 7. At x equal to 1, dy dx is equal to 9 minus 1 over 1 square. Then 9 minus 1 is equal to 8. Number 2. For each of the x-coordinates, state the conditions of the gradient of the tangents to the curve. At x equal to 1 over 4, the value of dy dx is negative. When the value of dy dx is less than 0, the tangent line will slant to the left. At x equal to 1, dy dx is equal to 8, which is a positive value. When the value of the dy dx is greater than 0, which is positive, then the tangent line will slant to the right. Questions B. Subsequently, finds the coordinates of the point where the tangent line is horizontal. When the tangent line is horizontal, this means the gradient of tangent is equal to 0. Then, dy dx is equal to 0. From questions 1a, we know that dy dx is equal to 9 minus 1 over x squared. This means 9 minus 1 over x squared is equal to 0. To solve this, next I'm going to get 9 equal to positive 1 over x squared. Then 9x squared equal to 1. Then x squared is equal to 1 over 9. Then x is equal to plus minus square root 1 over 9. Then the answer will be plus minus 1 over 3. So this plus minus 1 over 3 will be the x-coordinates of the points where the tangent line is horizontal. To find its y-coordinates, then we're going to substitute plus minus 1 over 3 into the equations of the curve. Starting with x equal to 1 over 3. Then 1 here will be 3 plus 3, which is equal to 6. And when x is equal to negative 1 over 3, then y will be negative 3 minus 3, which is negative 6. Then the coordinates will be 1 over 3, 6. Another one will be negative 1 over 3, negative 6. Questions number 2. The curve y equal to ax squared plus b over x has gradients negative 14 and 7 at x equal to 1 over 2 and x equal to 2 respectively. A. Determine the value of a and b. This means at x equal to 1 over 2, dy dx is equal to negative 14. And at x equal to 2, dy dx is equal to 7. So first we have to find the dy dx. So for the equations of the curve, I can write this as y equal to ax squared plus bx to the power of negative 1. dy dx is equal to 2ax minus bx to the power of negative 2. This is equal to 2ax minus b over x squared. To get the answer dy dx equal to negative 14, then we're going to substitute the x here with 1 over 2. So here we're going to get a minus 4b equal to negative 14. This will be the first equations. And to get the answer dy dx equal to 7, then we need to substitute the x with 2. Then 4a minus b over 4 equal to 7. To get rid of the fractions, so for every terms here, I'm going to multiply it by 4. This will be 16a minus, so the 4 here will be cancelled, then equal to 28. So here I'm going to solve these simultaneous linear equations using substitutions. For these equations, I'm going to write it as a equal to 4b minus 14. Then I'm going to label this as equation 1 and this as equations 2. To solve this, substitute 1 into equations 2. Next, we're going to get 64b minus 224 minus b equal to 28. Next, 63b equal to 224 plus 28, which is 252. Then b is equal to 252 divided by 63, which is equal to 4. To find the value of a, substitute b equal to 4 into equations 1. This is equal to 16 minus 14, which is 2. Questions B. Find the coordinates of the point on the curve where the gradient of tangent is 0. This means dy dx is equal to 0. This is the information that we get from questions A. To find the dy dx, substitute a with 2 and b with 4. Then dy dx is equal to 4x minus 4 over x squared. As dy dx equal to 0, then 4x minus 4 over x squared is equal to 0. Then, to get rid of the fractions, I'm going to multiply every terms here with x squared. Then we're going to get 4x cubed minus the x squared here will be cancelled, left with 4 equal to 0. Then 4x cubed equal to 4. X cubed equal to 4 divided by 4. Then x cubed equal to 1. Then x is equal to cube root of 1, which is 1. To find the y coordinate, then substitute x equal to 1 into the equations of the curve. Substitute the value of a and b into the curve, then this will be the equations. So when x equal to 1, y is equal to 2 plus 4, which is 6. Then the coordinates will be 1, 6.